In sections 4.2 and 4.3, you're going to run into some problems that ask you about rate and time, and they'll be referring to decay and half-life problems. When you get into those problems, again, some show up in 4.2, some show up in 4.3, but they're worked out very similarly. We're going to use one of these two formulas. T is equal to the natural log of A divided by P divided by R, or the R and the T flip-flop. So R is equal to the natural log of A divided by P, all divided by T. So now, what that means, where is this A, this P, this T, and this R coming from? If you remember, we have A equals PE to the RT. Okay? The A, the P, the R, and the T are from that formula. Okay? Specifically, we're going to use natural log of 2 for half-life and doubling problems. So instead of even worrying about A and P, we're going to simply put natural log of 2 and natural log of 2 if it's asking us about a half-life or a doubling problem. So these problems, we're only going to use this formula if we're looking for rate or if we're looking for time. Example 1, how long does it take for $1,000 to double at 7% compounded continuously? Convert to years and days. So I'm going to use the new formula, but I want to show you where this is coming from. So I have A is equal to PE to the RT, and I know that I'm using that formula because it says compounded continuously. Now A is how much you're going to have in the future. P is the starting amount, so I know my starting amount is 1,000. I want the money to double, so in the future I want to have 2,000. And then I'm going to have E to the R, which is 0.07, and I'm looking for T. Okay? This can be solved, but it's easier to use the new formula that I just showed you. When we're looking for time, we're going to use time is equal to the natural log. If it's talking about doubling, it's going to be 2 divided by the rate. The rate is 0.07. So in your calculator, you're going to do natural log of 2 divided by 0.07, and that's going to give you T is equal to 9.902102.579 years. Now I wrote that all out because the problem asks us to convert to years and days. So what you want to do is, obviously the whole number I know is years, so it's going to be 9 years. And then you're going to take this decimal part and you're going to multiply by 365, because there's 365 days in a year, and that's going to tell you what portion of a year we get. So 0.902102579 times 365 is going to give me 329 days. So my answer would be 9 years and 329 days. Example 2, the decay rate of a chemical is 7.4% per year, so they've given us the rate. What is its half-life? And again, when we're doing doubling or half-life problems, we're going to use the formula. T is equal to the natural log of 2 divided by the rate. The rate is 0.074. So go ahead and do that in your calculator, and you're going to get that T is equal to 9.4 years. Now it doesn't tell us to convert to years and days, so we can just round to one decimal place. 9.4 years. Example 3. The half-life of a chemical is 12 years, so they've given us the time. Find the decay rate. So this time we're looking for R. So we're just going to reverse our formula. Now we're going to use R equals the natural log of 2, and again we're using 2 because it says half-life, divided by the time, which is 12. Natural log of 2 divided by 12 gives me R equals 0.05776. And then to write that as a rate, I'm going to move the decimal 2 places to the left. So that's going to give me approximately 5.8% as my rate. Example 4, if $3,600 is invested in an account that compounds interest continuously, find the amount of time it would take for the account to grow to $5,400 at 4.75%. Again, I want to first just show you the setup if you're doing A equals PE to the RT. it's saying we want to have 5,400, so that's my A, is equal to P is 3,600, E to the R, which is 0.0475, times T. So we're looking for T. Again, you can set it up this way and solve this equation, but it's easier to use our formula of T is equal to, in this case, we're not doubling. Okay, 3,600 to 5,400 is not doubling. So that is why we're going to do 5,400 over 3,600, and we're going to do the natural log of that. So the 2 is for doubling, but we're not quite doubling here. All right, so it's natural log of A divided by P, and then we know the rate goes on the bottom, 0.0475. So T is going to be equal to the natural log of 1.5 divided by 0.0475. So again, we're not doubling, we're getting 1.5 times our money. That's going to leave me with T is approximately 8.5 years.